So we have here 5 points, and let's try to translate them using their indicated vectors. Again, we're trying to discuss this because later on, we're going to talk about the translation of a line using the indicated vector. So we can actually identify first the location of certain points or their translated images using vectors. We know the formula for that is actually identified in this manner. So we have here the translation of, say, a certain point x using a vector v is identified by adding up the components of your point x in your vector v. Okay? So in this case, for our first example, so this is our x sub 1, x sub 2, this is v sub 1 and v sub 2. So the translation of your point A using your vector v is actually equal to 2 plus negative 1, and then you have 3 plus negative 2. So you will have here the result, which is 2 minus 1 is 1, 3 minus 2 is also 1. This is its translation. Let's try to look that in our Cartesian plane. Considering that our Cartesian plane here actually with grids of 1, so our A is at 2 and 3. This is our A, okay, at 2 and 3. So its translation, we have here using the vector negative 1 and negative 2 is actually at 1 and 1. So we can see here that this is its translation at 1 and 1. This direction, take note, it goes down. Okay, so if you're going to place an arrowhead to that, that corresponds to our certain vector negative 1, negative 2. If we're going to plot negative 1, negative 2 solely on our Cartesian plane as a vector, it also looks like this. It goes down. So basically, that's our reform. Now let's try to continue with B, C, D, and E. But first, let's plot all of them on our Cartesian plane. So you have our B is at 5, 0. This is our B, 5 at 0. 4, C is 4 and then negative 2. So it's somewhere here. This is our C, 4, negative 2. Our D is at negative 5. 1, 2, 3, 4, 5. Negative 5 and positive 3. This is our D at 5 and negative 3. And then for our E is negative 3 and negative 4. Somewhere here. This is our E, negative 3, negative 4. Okay? So let's continue with the same process. So the translation of your point V on your vector V is actually again 5 plus 2 and then 0 plus 3. This is just equal to 7 and 3. Take note that our vector is at 2, 3, so it should be increasing if we're talking about plotting that singular vector on our line. Our Cartesian plane. So let's find out the location of our, let me use color blue for our translated images. So 7, we have here 7, and you have here 3. Sorry, it was actually, let me move my label for A somewhere here, because our point or the translated image of our V is at 7 and 3. So 7 and 3 somewhere here. This is our translated point for our B. So our B is somewhere here. So this movement, okay, sorry for that. This movement or this direction is of the vector 2 and 3. Sorry, I need to make it straighter, or at least attempt to make it straighter. Sorry for that. Okay, so how about C? So you have here D, translation of C with using the identified vector 4 plus 2, negative 2 plus 1. So you have here 6 and negative 1. Take note, 2, 1 is still positive, right? So hopefully we could come up with a positive direction as well. So our let me 6, so 1, 2, 3, 5, 6 and negative 1. Okay, sorry for that. Again, let me move this label for our B somewhere here, if it's okay with you, because our C is the translated image for our C is at 6 and negative 1. So this is the direction for 2 and 1. Okay, so you have here 6 and negative 1. Okay, let me continue with the rest of the examples here. So you will have for our D, the translation of our D using the vector given here. negative 5 plus negative 2, and you will have here 3 plus 3. So you will have the result of negative 7 and 6. Take note that the vector is identified with negative 2 and 3. So more or less, if we're going to plot that solely on the Cartesian plane, it goes towards upward motion on our second quadrant. So it should be in upward motion. Since our D is here, we are expecting that it should be upward motion. So you have negative 7. So negative 5, negative 7. Let me move this. Okay, somewhere here for our D. So we have negative 7 and then 6. 3, 4, 5, 6, right? So our translated image is at negative 7 and 6. As you can see, if this would be the origin, it goes to the direction of the vector. It goes to the second quadrant where x is negative and y is positive based on the vector. Okay, those were some concepts that you can bring to your what you call understanding. Now I would like to move this label for E because my vector for letter E is 5 and negative 2. That's actually, if we're going to plot that solely on the Cartesian plane, it's on the fourth quadrant. So I would be expecting movement downwards towards bottom right. So it would cover this. So let me move this here. I will be expecting a point somewhere in this direction as this moves towards that. Okay, those were some hints that you could actually look at, but of course it pays to really check that here. Negative 3 plus 5 and negative 4 plus negative 2. So you will have here the result positive 2, and then you will have here negative 6. Again, positive 2, yeah, right, negative 6. Let us try to locate that here. So positive 2 is somewhere here, negative 6, so negative 4, 5, and 6. And yes, our point is somewhere here. As you can see, the direction is really going towards a fourth quadrant if this would be our origin, right? So that is why it looks like that. So we can see from these results that our points were translated using the indicated vectors. We have here 2 and 3 for A, okay, with its image is at 1 and 1. The image of B is actually at 7 and 3. Okay, the image of C is at 6 and negative 1. The image of D is at negative 7 and 6. And the image, or the translated image for E, is at 2 and negative 6. Now imagine if we were going to translate now lines, and lines consist of points. So basically we have to use the same process, but now intending for a line which composed of infinitely many points. We will be discussing that in the next video, so please stay tuned. Thank you very much for watching.